Okay, so we're on to lesson 7, talking about overall efficiency. So we already did this when we did unit 2, when we're talking about the efficiency of simple machine. We would go percent efficiency equals to the energy output divided by the energy input times 100%. So think about output as in kind of what you intended the object to do, okay? And then think about the input would be like when you need to plug something in and you get the electricity or something like that. Okay? So it's like kind of you're plugged in how much you actually need to use up in order to get your objects to do what it's supposed to do. So intended purpose could be, oh, if I want light bulbs to give off light. That's the intended purpose. But then sometimes light energy is given off, but also heat. I don't need my light bulb to get hot. So the hot is converted into a waste energy. So then it's not 100% efficiency. And most of the energy, we talked about that before already. Most of the energy loss happens in a thermal energy type. Okay, so let's take a look at this. Calculate percent efficiency of a light bulb if 80 joules of energy is used. 80 joules is used to produce light output of 12. Okay, so we already know we're dealing with percent efficiency, right? So we said that the E out divided by the E in is times 100%. We're going to do a summary together, okay? We want percent efficiency. That's what I'm looking for. Okay, and they tell you that you have 80 joules of energy is used, and then the light output. So if you need to decide which one is out and in, hopefully the wordings can kind of help hint to you. So if the output is the light, which is 12, does it make sense that the other one is going to have to be in? In is, what you actually used up. Okay, so 80 joules. So I'm going to throw it into this equation. E output is 12. And V input is 80, and I multiply it by 100%. I still have people who have a hard time dealing with these questions. I need you to take your percentage and write your percentage at the bottom. Then on your calculator, you would only deal with the number part. Okay, so you would go 12 divided by 80 times 100. And then whatever that answer is, it's in percentage. That's the unit. So I should have something like a 15%. Okay, so only 15% of your light is being used as a light. The rest are like wasted as heat. Even the LEDs, people say it's better. It's still 15%. If you're talking about incandescent light bulb, the old kind that have the filament that heats up when it gets really, really hot. I remember burning my hand when I was trying to change a light bulb one time on an incandescent light bulb. It's like 5% efficiency. 95% is actually wasted at heat. Okay? All right, so this is just a review. Hopefully this is okay. Then we're talking about this thing called the overall efficiency. So we're talking about technology that have multiple things that you can lose energy. Okay? How to find the overall efficiency is basically you keep multiplying the efficiency together. And in this case, we're not going to be using percentage. Instead of saying, if I tell you the efficiency is 70%, and I want you to plug it into this equation that you can use, you actually need to convert it so that it's not a percentage. So in order to go from percentage to a non-percentage, you would just divide the number by 100. So energy flow chart. So it's almost like an oven mitt. You will need to draw pictures like an oven mitt, and basically telling how much energy is wasted and then how many output you have. Okay, so it shows the total energy as the input will decrease and indicate that it got transformed to something else. Okay, so this question. Determine overall efficiency of an oil furnace given the following energy transformation. The extracting the oil is 97% efficiency, transporting the oil is 97, and then the oil furnace is 75. So we basically have different efficiency. If you go back to the question, it's basically efficient 1 times 2 times 3. So let's write them out. So efficient 1 is 97%. Remember how I said we don't use the percentage in this equation. So I'm just going to write the equation out first. So efficiency overall. So efficiency overall is equals to EFF1 times 2 times 3. There are 3 in here. Okay, efficiency 1 is 97%. We have to change it to the decimal of it. So we divide it. So remember, we would divide it by 100, okay? To go from percentage to the number. Efficiency 2 is 97% again, so 0.97. Efficiency 3 is 0.75. So the key thing is please divide it by 100. And so the overall is you just multiply them together. Okay, so 0.97 times 0.97 times 0.75. So instead of 100% that you started off with, if I have multiple things that I could possibly lose energy, my percent total efficiency is 0.71. Okay, or in another word, you are left with 71% of whatever you had before. Okay, last one. Woo, super humongous picture. The energy flow diagram. It's for electrical heating system. Calculate the values of A, B, C, and D, and show the percentage of the original energy remaining after each energy transformation. Okay, so the first one tells you started off with 100 and you lost 95%. I mean, you only extract 95% of it. So if you were to write the equation, it would be the original multiplied by the 95%, meaning the 0.95. So you right now have 95% left. Okay, if I have 95% of them left, I have lost 5%. Are we okay with that? Like if you have $100 and you lost 5% from interest or from, I don't know, compound whatever. From interest, you would have $95 left. Okay? And then now, if I only have 95 left, and I'm telling you now I have only 96% left, then to calculate part B, I'm going to take whatever I had before. So I take this value, but now I have to multiply it by 0.96. So 95 times 0.96. So I'm ending up with 91.2%. Okay, take this new value, figure out what is the percentage loss. Ooh, this one's a whole lot. I have 42% left. That means I have to times 0.42. So divide that by 100 always. So 38.3% is left. And that goes to the next one. The next one has 38.3, but I only have 38% that got taken. So 0.38. 38% with only 38% left, I now have 14.6%. And that's the overall, like how much, like think of all the energy production from 100% because I'm extracting oil, transportation, and doing other stuff. What actually gets to your home is 14